All right, scalar multiplication. So this scalar just is a fancy mathematical term for real number value. That's all scalar means. So scalar just means I'm going to multiply by a real number value. What's different here than what we did in chapter 3 is I'm multiplying the entire matrix. In chapter 3 we just multiplied rows because rows represented equations. Here they don't. And so we're going to multiply by k, my scalar, my real number value k, by my matrix A. And what you do is you just basically make sure, it's a big distributive step. You just make sure you multiply everything, every row, every column, by that k value. And so to look at a simple example, I'm actually going to do two multiplications with my t. The first one, so I've got my t here, which is a 2 by 3. All right, 2 rows, 3 columns. And so the first one is I'm going to take t and multiply. And the reason why I'd probably multiply by 3 is if I multiply by 3, I get rid of my fractions. And so it's just a big distributive step. I'm going to take 3 and multiply it by this entire matrix. Instead of a single row, it's all of my rows. And so again, everything inside here gets multiplied by a 3. And so 1/3 gets multiplied by 3. Well, that simplifies to 1. 3 times negative 9 is negative 27. 3 times 2 is 6. 4 times 3 is 12. Here my 3 and my negative 2/3 leave me with a negative 2. And then I get a 1 times 3. And so there is my 3 times c. And again, one reason I might do that is to get rid of fractions, right? Might multiply it out. Another common multiplication that we use is multiplying through by a negative 1. So I take negative 1 times my matrix T. And I'll explain why this is a common one we like to use. Which, again, basically just means multiply everything inside by negative 1. And so everything gets flipped in its sign. What was a positive becomes a negative. What was a negative becomes a positive. So I get negative 1/3, positive 9, negative 2, negative 4, 2/3, positive 2/3, and negative 1. And one reason why we might do that is if you remember the previous example on the last video, the very last one we did, I had A minus B. And remember I said minus is always, at least for me, it's a little tricky. And so I'll use a little trick to get around the minus case. And so what I'll do is I'll use this. Right. I can change subtraction to add by the opposite. It's the exact same. And so what I will do, instead of taking matrix A minus matrix B, I'll take matrix A and I'll add to it negative 1 times my matrix B. Right? So again, I didn't change anything. That's the same thing, right? If I take 2 minus 3, it's exactly the same as 2 plus negative 3. Right? Both cases, I get negative 1 out. And that's really all I'm doing here. What this is allowing me to do is kind of get around that negative so that it doesn't throw me off. And addition's always easier than subtraction. It's really easy to multiply through by a negative 1, right? If I multiply through by a negative 1, all I'm doing is changing my sign on every single term. And that's kind of a trick that I will use to get around a little bit of dealing with the negative. All right, so we'll stop there. We'll pick up example 3 and 4 in the next video.